Hello everyone. This is Siddharth from InfoTech, anchoring today's webinar and supporting the event logistically. Welcome to our latest webinar to the series of webinars we have been organizing on test automation research and development. On behalf of InfoTech, I would like to thank and welcome you all to this web event on an adaptive framework for test automation. Please join Ramandeep Singh, our Senior Manager Test Automation, and Anshul Mathur, QA Lead of our Test Automation team, as they discuss this along with a demonstration to help illustrate the concept better. Before we start, I would like to inform you that you can send your questions to us anytime during the web event using the Questions tab on GoToWebinar platform. At the end of the session, we will try to answer all the questions received during this web event. All participants are on mute at this time to allow for the speakers to present. Over to Raman now.
Thank you, Siddharth. Once again, welcome to this webinar presentation on test automation. Quality engineering has evolved a lot in the past decade, especially in our ways of building test automation solutions. The test automation group at InfoTech has evolved with the industry due to our commitment for continuous innovation in test automation. From commercial test automation tools to open source test libraries to creating our own test automation solutions, we have good experiences in all these areas. But one question has always haunted test automation industry: how to get the return on investment. Test automation has always been looked at as high resource intensive process. With development teams moving towards aggressive, agile, and leaner application development models, this question has become even more evident. It takes efforts to bring automated tests to a state where they can be effectively utilized in testing of the application under development. But with smaller sprints and leaner development cycles, test automation always ends up with huge backlog, and hence test automation always trails behind, usually 1, 2, and at times even more number of sprints behind the development cycles. So how do we make sure that test automation development goes hand in hand with the application development so that automated testing can be utilized effectively? How do we do in-sprint test automation and make test automation committed to current sprint cycle? How can we enable our test automation frameworks to do in-sprint test automation? Well, we at InfoTech have done a lot of research to solve some of these problems. A review of the framework design, composition of the test cases, and the process of test automation has helped us to do more innovation. Today, through this webinar, we're going to present some of these ideas and some concepts. These concepts and innovations using which we are able to address most of these concerns. Remember that the goal is to make test automation development efficient and effective. But in order to do that, we need to make sure that we're able to do in-sprint test automation development so that automated tests can be executed in the same sprint and regression tests can be executed in all future sprints. This would make test automation effective as well as affordable. I will now hand over the controls to Anshul, who would guide you through the rest of the content of the webinar. He would present the solution along with a bunch of demos, which shows how we are able to solve these problems and challenges. So over to Anshul.
Thanks a lot, Ramandeep, for this introduction. And hello, everyone. Before we move on to the agenda, let me talk briefly about the need of coming up with the said approach. We have come a long way in terms of software testing and quality assurance. The transitions in the role of a software tester and contribution of test automation in the overall product life cycle. But there are a lot of gaps that still exist between how we manage our test cases and how we automate them. Moreover, bringing the functional and automation engineers closer is yet another area that needs attention. The framework that we propose is an attempt to bridge these gaps and deliver a seamless automation testing experience. The framework has this word adaptive in its name because it can work efficiently with a variety of test management plugins, which are used across different defect management tools. So let's begin the session and find out how the framework benefits the process and leverages the quality of output produced by the product team. First of all, let me walk you all through today's agenda. In the beginning, I will share a couple of interesting and important statistics, which will actually lead us to the problem areas. After analyzing these problems, we'll take a close look at the available resolutions. Then we should see the missing stone in the wall, which is effectively filled up by the solution that we propose. We will then go through the entire architecture of the framework, followed by a working demonstration. After that, I will talk about a couple of requirements and limitations associated with the framework. And finally, the conclusion. All right, so here is a survey recently conducted by Intersolve. Intersolve is a mobile development company based out of US. The survey reveals that 80% of the QA organizations invest into automation of test cases around their product. But a lot of efforts are applied in carrying out the manual tasks. As this graph shows that 56% of the organizations have their automation engineers do manual bug tracking, which is indeed a huge number. Similarly, 45% of the automation engineers needs to take care of closing defects manually. Yet another manual task is test case scripting, which takes a share of about 40%. Moving on to the next slide, here is another survey which discloses even more surprising facts. This graph is generated based on the degree of automation done at the different testing levels. For unit testing, more than 25% of the organizations do 100% automation. Further, as far as automation of the integration tests and the system tests are concerned, a considerable amount of coverage is done through automation. But when it comes to acceptance test automation, the story has a different face altogether. Only 3% firms do automation for all their acceptance tests. Or just let us see the other side. About 42% of these firms do not go for any acceptance test automation. These numbers are surprising because we are in the era of agile methodologies where acceptance criteria are the most realistic sources of truth for each user behavior. Based on these statistics, we can now move on to the problem area. Let us analyze the problem that comes out of these facts. First and foremost, a lot of manual effort is involved in managing and tracking the defect. While you may have created automation scripts for many or all of the defects which could be executed over and over for regression, publishing the execution results against each defect on the test management tool is again part of the manual task. This essentially means that there is a lack of integration between the functional tool and the automated script. Another problem is a very low degree of acceptance test automation. Since a lot of coding skills are required in scripting the test cases, functional team is not able to connect well with the automated tests Not only that, even when the automated script execution reports are shared with the functional engineers, it is tough for them to debug the report and find out the root causes behind any test failure. And this is quite understandable. Test case maintenance is one more problem that has a great impact. A huge gap lies between the test case repositories, which are managed and maintained by the functional testing team, and the test automation artifacts, which are managed by the automation testing team. So effectively, we have two separate components that work without being in sync together in one single testing effort. Now, having discussed a lot about these existing problems, let us switch the context towards the available resolutions for some of them. One of the solutions is writing down the test cases in human readable format. Instead of creating the test cases in our traditional ways, which involve defining the prerequisites, the steps to reproduce actual and expected results, we have moved towards feature-based testing, where we write user stories that depict user behaviors across all the components of a system. These user stories are implemented in form of features, and every feature has a role associated with it. With every feature comes an acceptance criteria, which involves a lot of scenarios around that feature. These acceptance criteria are not just the specification of the user behavior, but they're also the functional tests. And of course, every acceptance criteria is a single source of truth for that particular behavior. One such good example of an acceptance test is this narrative, which says LMS assignment taking. This narrative is about that a student wants to access an assignment that is created by an instructor so that he can submit the assignment for grading. One scenario that could be derived out of this narrative could be assignment take by a student. Now, there are a lot of steps associated with these scenarios written in the BDD style, having given, when, and then against each step. So given are essentially the prerequisites, when are the actions that are being performed by the user on the system, and then involves all the validations and tracking the responses of the system. So for this scenario, given is a student who has to be enrolled in a course, and instructor was created an assignment. When I log in as a student and navigate to the assignment section, then I should see the new assignment, and I'm able to attempt and submit the assignment. Now, to implement an automated test suite for such a requirement, we need to create a modular framework, a framework that could be employed in the agile process of testing. This is how a generic automation framework looks like, which enables a component-based approach, where we keep the test cases as a separate tier and the test vocabulary as an independent module. The other parts of the framework involves the automation API that takes care of all the user actions on the given system under test, and the page objects repository, which holds the various UI locators. As you can see, there is a clear distinction between these components, as each one of these is a self-dependent entity that could be modified without impacting the others. A very good approach to speed up test automation process is to diversify the test coverage. We can optimize the cost and coverage associated with the automation efforts by writing and automating hybrid test cases. Now by hybrid test cases, we mean that a set of tests that target the application not only at the UI level, but also at the service level and the unit level. Automating a high number of unit tests essentially means that we need not wait for the application UI to be available for creating a test suite. Now, imagine that we are not using any test management tool. So traditionally, we've been using Excel sheets to manage the test cases in form of steps to reproduce expected results and etc. In the recent past, there have been a lot of test management systems like Zephyr, TestRails, Jira, and many more that has allowed a more organized way of writing and tracking the test cases. But when it comes to the agile world we are in, it is indeed not possible to execute all test cases in each cycle, which implies that we still need a better approach to integrate feature testing in the test management tool. Hence, there have been such an integration already available for tools with defect tracking mechanisms. Examples of these integrations is Zephyr or Behave plugins that are available for Jira. A similar combination is TestRails that comes with Redmine. However, the problem that still exists is the two-way communication. The automation script is still not able to communicate with the defect tracking tool. Or let's say automation scripts work separately and are not able to connect with how the tests are managed in the test management systems. This forms the basis of the solution that we propose. To a two-way communication, a framework that integrates automation with the defect tracking and test case management. The concept behind developing such a framework is to club variety of activities together into a single automated approach. So what we do is club test case scripting, test case execution, and test reporting, all of them together in a single bunch of automated activities. The idea is based on the fact that the data can be moved over the net from one place to the other based on a set of API calls. In general, we write test cases for each and every defect that is there on the defect tracking tool. Once we have created a user story for each defect, we can start driving the automation from the defect management tool itself, because the automation script is capable of reading the user stories which are available on the defect tracking tool and convert those acceptance criteria into scenarios which are readily executable by the automation scripts. This way, we are able to manage the defects from the automation system, because eventually, once the execution completes, the results are posted back to the defect tracking tool by the automation script itself. Let's talk a bit about the process architecture, which will clarify more pictorially about this process. This is an agile board on the defect tracking tool with a lot of user stories written and managed using a test management plugin. Now that we are talking about acceptance test automation, all the user stories are written generally in DDD style, just the same way as we discussed, which is given, when, then format. So the very first step in the overall process is to convert these acceptance criteria written in the user stories on the defect tracking tool into the test classes within the automation script. Now the automation script does it by itself based on a combination of REST API calls. Once the acceptance criteria are converted into executable test classes, execution is triggered by the automation script, which is based on one or the other build tool. Next step after execution is report generation. Now, the results which are generated after executing the scenarios would essentially involve the fact that what acceptance criteria have been met and what all have failed. Now, these results need to be posted back on the user story to complete the process. This is again taken care of by the automation script itself. So what the automation script does is capture the results and post them back on the user story in form of a comment. Once the comments are placed on the user story, next step in the process is to transit the status of the story to the required state. So in case all the acceptance criteria are met, the story is moved to the done state. In case there is any failure of any of the acceptance criteria, the story can be moved back to the to-do state, where everyone would be informed that there is some more work which is required to be done on the story. Let me take you all through a working demo of this process. This is an agile Jira board that you are right now viewing on your screen. For the sake of the demo, we have used Jira as our defect tracking tool, and we have used Behave plugin for writing our test cases in the BDD format. This agile board shows that one of the tickets, which is ATD1, is yet not started and is rightly placed in the to-do state, while there are two other user stories placed in the ready for QA state. Now, here is the time when the testers need to jump in and perform and carry out the tests against these user stories. So let us see how automation scripts work in this case. The first step that script would do is find out what actually needs to be executed. So with this command, we initiate the build process for the project. In the command line, we've given the browser and the environment for which we need to run our tests, and this is configurable. Now, project is being built now. The next thing in the process is to find out what tickets needs to be automated. And you would see in the logs, just as you can do it right now, that ATD3 and ATD2 are the two tickets that fall into ready for QA status and needs to be executed. The scenarios associated with these stories are based on one of the web applications, which is imdb.com. What we have done is created simple tests around this web application. The first of the tests would try and find out a movie which doesn't exist and check if the user is navigated to a no results page. So just for automation, we are using Selenium since this is a web-based application. Now the first test has been executed completely. Let us move to the next story execution. The scenario is user is able to navigate to the help page. Let the browser open. Script has clicked on the help link. Now let us see what kind of results are generated on the log. Now here the execution completes. Now as you can see, the log says that there have been two stories which were executed. One of them, ATD2, which had the scenario saying user is able to navigate to the help page, has failed. Similarly, the other story, which says user reaches the no search result page on searching an invalid movie name, has passed. The next step in the process is to put up the comments on the user story and make the transition of the story to the right state. And this is actually taken care of by the automation script itself. As you can see in the logs, it has printed closing Jira ticket ATD2 because all the acceptance criteria in the scenario has passed. But when it comes to ATD3, it has reopened since there is a failure which is logged for that scenario. Let us see how the Jira board now looks like. And here you go. So ATD3, which initially was in the ready for QA status, has joined ATD1 in the to-do state. This has happened because one or more acceptance criteria within the user story has failed. Similarly, ATD2, the user story in which all the acceptance criteria has passed, is moved automatically to the done state. Let us see what kind of comments does an automation script make on the user story. Let's take an example of ATD3, which has been moved to the to-do state. Here you see an example of the comment that can be made. So the scenario is marked with a failure against it and has been changed to red and color. And this scenario has failed because the last step, which says I should land on help page, has failed. And since there is one failure, the story has rightly been moved to the to-do state. Let's talk about the ATD2 story, which has been moved to the done state. Now, as you can see, all the comments says that the acceptance criteria has passed, and hence the scenario is treated to be passed and moved to the done state. Let us come back to the presentation and take it forward. Now, there are a lot of other features which have already been incorporated in this approach. Let's talk a bit about these features. Instead of parsing the complete agile board, which we just did in the demonstration, and execute a lot of the stories at one go, the framework could be modified to pick up and execute a specific story based on the story ID. We can control the story ID from the command line itself, which makes sure that unique stories could be executed at different times. Another flexibility in the framework is that if the teams decide to skip changing the status of a story by the script, that part of the code can be avoided while execution without impacting any other activity. Essentially, automation process will complete as soon as the script posts back the results. One great feature of this framework is that if any step mentioned on the story do not have a corresponding code implementation, an automated email will be sent to the test developer, giving the information about the pending steps. The engineer can then quickly implement the step in the automation code base and initiate the build process for validation. We have also come up with a strategy to leave automated execution of a step that needs to be tested manually. The framework has that capability to read a tag, something like manual, in each story, which could be placed against any step, and skip executing that particular step. But the execution doesn't end here. The framework has the capability of capturing a snapshot of the state of the application at that particular manual step. And once execution of all the other steps is done, the script posts back the screenshot along with the comments on the user story. In this case, transiting stories from one state to the other is left to the functional engineer. Let's talk a bit about the outcomes of this proposed framework. A lot of manual effort, which previously was involved in defect tracking, can now be reduced to just about negligible. All the defects for which we have created a user story on the defect tracking tool can now be tracked by the automation scripts only. As soon as a defect is moved to the ready for QA status, the automation script can start executing it and post the results back. This way, each defect has an associated script, and regressing a bug would now be an easier and less time-consuming task. Moving on to the next outcome, as we've already discussed that once the automation script results are posted back, status of a story can be changed accordingly. This removes any manual dependency on the functional team for assigning the story to the concerned team member or close it if required. Another important benefit of using such a framework is to enhance the productivity of an automation engineer. Now that all the efforts required in managing the story are automated, since its creation, an automation engineer can focus more on building the test logics rather than simply designing the test classes. Now, let me take you through a couple of requirements which are with which the framework is done. One of them is a close coordination between the team members. The team members in this case involve all the developers, the functional testing engineers, and the automation engineer, because all of them have now to be on the same page all the time, because this is a real quick process and without any manual intervention. The other requirement for this system to be ahead is high quality automation scripts. Now that we are relying heavily on the quality of automation scripts and we have curbed down any manual effort in changing status of any story, we need to make sure that there are no false positive results coming out on executing the automation scripts. One limitation around this framework is the exposure of APIs. The whole system is based on establishing a communication between the automation scripts and the test management plugin. So there is an indispensable need of having these APIs available to the automation scripts, or otherwise the complete system would not even initiate. Let's come to the conclusion of this presentation. The paradigm with which we started off, which is in-sprint test automation, has now become a possibility. Now that an automation script is ready, as soon as a user story is created on the defect tracking tool, all stories in the same sprint are automatically automated. This makes in-sprint test automation a reality. Another important aspect is transition of a story. Now, story could be moved to the right state without any manual effort. Functional team can now judge what needs to be executed. Now that any effort from an automation engineer is removed for creating the test scripts, it is the functional team who holds the power to define what should the automation scripts do, because the user stories which have been created by the functional team are essentially what is being executed by the automation script. Automation is now taken to the next level, because now we're not just automating the tests, but we are actually automating the overall process. The process that involves writing the test cases, executing the test cases, posting the results back on the user story, and changing status of a story. With this, I would like to pass on the control to Ramandeep to take this forward. Ramandeep, it's all yours.
Thank you, Anshul. Like we have seen today, the solution is a multi-folded approach. Build and control the test automation framework, build test management integrations, and build acceptance tests with diversified test coverage. The test coverage must be diversified across different layers of the application. Automation of a test must happen at place where it is most effective to script. Tests at lower layers like API and data can be created much ahead in the development cycle, as they have limited interactions. UI and UX tests, on the other hand, though provide vast coverage across complete system, but can only be built once some insight about the user interface is known. With effective test automation frameworks that are created on an agile architecture, some part of your UI test automation can still be completed way before the UI designs are available. And with behavior-driven way of defining the test cases, just what Anshul demonstrated today, scripting would become just a filler activity in presence of a domain-specific language, like a fixed vocabulary for the actions and activities happening inside the application under test. We have implemented this solution for multiple clients, and some of them are effectively using all or some of the concepts of the workflows, the concept workflows. One of the implementation we did was using Jira's Zephyr plugin, where the tests are written in a BDD format, essentially the Cucumber language. Also, the solution is capable of all features desired out of a standard test automation framework, be it reporting, continuous integration, test data management, API and UI test automation coverage, in-browser UI layout testing, etc. Essentially, all the desired capabilities that we need in a test automation framework, this adaptive framework has all those things alongside the test management tool integration. We're also working on expanding the framework to allow integration with TestLink and other test and project management tools. The framework solution that we built at InfoTech are built on the philosophy of extendability. The design of the framework and implemented code makes it easy to extend the feature sets to enable integration in future with other testing and development processes and tools. Also, like Anshul said, the features are highly customizable, so we can refine the workflow depending on the need of the project team. Also, the example that Anshul demonstrated today was built on Java as the programming language, but we have versions of the solution built using other programming language as well, like Ruby. In fact, one of the implementation on Zephyr is working on top of Ruby with Cucumber as the test runner and Selenium and Selendroid as the test automation and test execution tools. So with such a framework in place and some conceptual changes like using acceptance tests as the core of the testing, we can make test automation development leaner and more efficient, which makes in-sprint test automation possible. With this, we're done, and I'm passing it over to Siddharth for any questions that may have been asked through the chat window. So over to Siddharth.
Thank you, Anshul and Raman. I believe this was very informative and must have generated some interest in our audience. We'll now start with the Q&A phase, so let's start looking at the questions that we have received. Okay, so the first one that we have is, can we leverage the same setup for integrating performance tests to Agile Board or Jira? Raman?
Well, that's definitely a very interesting question. performance testing as such, so performance testing as such is actually a process that we see that should reside outside our standard testing cycles and approaches. Normally in agile process, we would not prefer doing performance tests, which essentially are doing stress testing, doing load testing of the application aside functional testing of the application. So in a way, you cannot actually describe your performance test the way you describe your functional test in an acceptance criteria format, in a behavior-driven format. Although from a technological perspective, it can definitely be done. We can use JMeter as our performance test tool underneath, and the framework can take care of that when you start building your performance test scenarios right out of Jira and run them from your tool, and all the reports go directly into Jira. That integration definitely is possible, but it is not something that is recommended. So the answer is, the straight answer is yes, it is possible. The bigger answer, we might not actually want that in our overall cycle.
Okay, interesting. So let's move on to the second one. This is, could this approach be used to automatically log defects also? Maybe this is about logging the defects in Jira because we are using that as an integration tool. Anshu?
Yes, absolutely. I believe that once we get the access to the test management system API, for each story that fails, we can create a corresponding defect that could be raised by creating a new issue with the same summary as that of the story. We might append some things like defect and make the issue type as bug. And since the framework is based on the concept of REST API calls, once we are able to communicate with the defect tracking tools API, we can log the defects automatically, yes.
Okay, thank you. Okay, this one. Okay, so the question is, what is the amount of time estimated to create the automation test to be ready for each new sprint? Okay, and it's actually another part of the question, which is, how long would it take to be up and running and having the ability to run the test in 2-week sprints?
Well, that is where something that Anshul demonstrated in the in one of his slides really helps. The way we create the framework here is that the framework in general is a modular framework built on top of multiple different components, such that each of those components can independently be developed on the side, and whenever they are needed, they can be integrated to put in together all the test pieces together and run the tests. Now, when you think of, when you put everything down to a 2-week sprint, essentially first thing that you need to make sure that is that you have all your background work done. And by background work, we mean is all your lower pieces of the framework created. What you might need to do within that 2-week sprint is to build that vocabulary, that is the function library for the necessary acceptance criteria within that sprint, and then make sure that that function library is available. Now, that is where your automation engineer skills would be put into practice, where he can figure out, according to whatever stories are available in the sprint, what are those vocabularies, what are those DSL keywords that has to be created. And automation is all, in this case, automation would all be just scripting those DSL keywords. All the lower level essential things of the framework would already be created before we start implementing the framework itself, or when we implement the complete framework itself. And hence, it would not take a lot of time for anybody to build just those DSL keywords. Now, in addition, if you're talking about UI automation, we might not also we might also need to fill in the page objects or object repositories for the new objects that come in. that have to be interacted in a user story. Now, if you look at this, your vocabulary, the DSLs can be created without the knowledge of the page objects, without the knowledge of the UI. And once the UI is available, some automation engineer can come in and he can start building your page objects. Since these two tasks are independent and can happen at two different times in your sprint cycle, it becomes really easy to tackle them within the same sprint, and even at times do them simultaneously, and yet be ready with the complete automation within the same sprint. I hope that answers the question.
Thanks, Raman. Let me just ask the next question then. How can I automate my existing regression tests with this approach? Anshul?
Yeah, it shouldn't really matter whether your test cases fall under the current sprint or the previous one, because this approach would work. I mean, as long as the stories are written in a way by which a mapping could be done between each step of the story and the automated test. Just as Raman said, once we have the functional DSL available, the framework can now set up a way to automate every story, be it the part of regression suite or the current sprint. So yes.
Okay. Raman, this next one is again for you. So whenever a story is moved to ready for QA, the automation script is executed and updated the status in the comments and moves the story to respective swim lanes like done or open, right? So what automation tool is used for updating the comments and status? Is it the same Selenium?
No, not really. Yeah, one way could be to use Selenium to automate your test management tool itself and the bug tracking tool itself. But that is, the one implementation that we'll prefer at the far end. But what we have done and what we recommend doing in our implementation is to be able to integrate with the API of your test management as well as bug tracking and project management tools. In this case, what we have done in the demo that Anshul showed, we have done the integration with Jira as well as the Behave plugin in Jira through its API, through its open API. In fact, Anshul also did mention that this is a requirement for this framework to work, that whatever tools that you're using, the test management tools, the project management tools, their API needs to be open so that we can utilize those API calls inside the framework itself. In fact, that is one of the next steps that we are trying to do, is we're trying to, by default, make sure that the framework already has the necessary API calls ready for all the major project management and test management tools. We've already done this for Zephyr in Jira. We've already done this for Behave in Jira. We've already done this for the standalone Zephyr. We are doing it for TestLink. And then once we're done that, we are also, we have in pipeline some other major test management and project management tools which we'll do the integration with.
Quick one for you, Raman. So is this another form of continuous integration?
That's actually a very interesting question. Yes, you can call this as continuous test integration, because we are trying to build everything within the same sprint. And as the story is available to QA, we're trying to make sure that the automation is also ready. So yes, this kind of is continuous automated test integration.
Okay. A couple of more. Okay. So in this approach, you're talking about raising defects in case of failures automatically, right? But isn't it advisable to check first the issue manually and then raise the bugs, because it may be some sort of a data issue or an environment issue? It may be a false alarm due to which the scripts are getting failed. So what do you suggest? Should it be done automatically or should it be verified first manually?
Well, that is a case that even we are dealing with in some of the projects. So here is the thing. This is how we have handled it. The first thing is, because if you build this kind of a system where even your defect logging is automated, the onus of the quality of defects becomes goes to the test automation code. You need to be you need to have a very high quality and precise test automation code so that there are no chances of false failures. But if you know, when you're dealing with UI test automation, dealing with Selenium-based tests, the chances of false failures are still pretty high. But in that case, how do you handle it? Well, the framework has this feature. Essentially, you can customize the feature where the framework would just mark the comments in the story, move it to the necessary bucket, but it will not log a defect for that subsequent failure. And then there has to be one manual intervention. A manual person has to come in, and he has to validate the failure, and then he can choose to log a defect or not log a defect. So depending on what kind of quality of automation you are able to build, you can decide to enable or disable this automated bug logging feature in the framework.
Okay, I believe this is the final one. So what would be the startup handout for proceeding towards the framework? What's the starting point? How do you implement it, basically?
So we what we have done is we have all the necessary starting lower pieces of framework ready with us. We just need to understand the requirement of the project, the workflows of the project, and once we understand that, we can put together all the pieces and integrate the workflow in the test automation code. So the first thing essentially would be to understand the test workflow, to understand the project lifecycle, project development workflow, and then we can customize the framework based on that workflow to essentially take care of the automation in that project.
Okay, there's just another question that's just come up. So the participant has asked, in their organization, they are probably putting more stress on DB level testing and manual testing. In that particular scenario, how would you go about implementing this approach?
Right. So that is where we are saying building more of acceptance tests at diversified layers is important. You know, I totally understand why we want to go more of DB testing, because some majority of the content and the model-related functionality and the model-related business logic is absolutely coded in the database itself. And it really is more efficient to do testing at that level. Well, the framework as such has all the necessary tools to be able to do testing at any of the layers of the automation of the application, whether it's the DB layer, whether it's the content layer, whether it's the APIs, the RESTful services, the SOAP services, the WCF, or whether it's the UI or the mobile app for that matter. If it's the database that you want to test, you continue writing your test cases in the behavior-driven format, or even if you do not write your test cases in the behavior-driven format, you still have the test cases in some form. Those test cases can be consumed inside the framework, and we can write that necessary essential customization in the framework to be able to understand the test cases that you've written in your format, and then consume them in automated test scripts. And then the same workflow can apply that what Anshul has demonstrated, the same workflow of making sure that the tests are driven through your test management tool, the automation, execution, and the results are going back to the test management tool.
Okay, we are still getting questions. Probably this is the last one because we are almost out of time now. So can this framework be made similar to the page object model?
This so this framework internally essentially uses the page object model concept. If you look at the lower level architecture design of this framework, in fact, that is how we are making sure that the framework is agile in nature, and the overall time it takes to build the UI actions is really low because we are using the page object concept. So yes, the whole design essentially uses page object concept.
Okay, just last one. So the question is, have we done automation of Chrome app? If yes, then how?
an app built for Chrome OS?
I believe so. The question is not clear, but I think that's the intent.
Well, so far, I personally have not done any project which involves automation of Chrome app. We've done automation of Android-based applications, iOS-based applications. I don't think, luckily because Chrome OS is Google's OS, they normally have the tendency of making the APIs available and the SDKs available freely. So I don't think doing automation would be that difficult.
Okay, so the clarification is actually they're asking about the apps launched from Chrome extensions.
Apps launched from Chrome extensions.
So wherever there is involvement of Chrome extensions in the applications.
Yes, we have not done any such automation. I can understand where the problem is because you would not be able to use Selenium for doing such kind of automation.
Right.
But I think that the SDK is open for, the SDK definitely is open for the extension. So we can hook up something around the SDK to be able to do automation. I'm not really sure right now because we have not done anything around that area, but that is an interesting perspective to start looking at.
Okay, so maybe this can be the next concept of our webinar. Maybe we can start exploring this and then have another webinar on this.
Sure, interesting idea.
Okay, good. So we have almost run out of time now. So let me just close this session by thanking you all for joining us in this web event and spending your valuable time with us. We hope you found it useful and informative. I would also like to thank the presenters for sharing this new development and their insights with all of us. Please note that if there are still any questions you would like to discuss, feel free to write back to us and we'll get back to you at the earliest. You will soon receive a short survey about today's web event, and we would really appreciate if you could please take a few minutes and provide your valuable feedback. You may log off at this time. Have a nice day.